Welcome to Pyrography Made Easy. I'm Brenda. In this episode, I am going to be doing a review of the ProStormer heat gun. I saw this on Valerie's Drawing with Fire YouTube channel, and after I saw her using it, I thought, I have got to get one. I have always wanted something that you could use like an airbrush to quickly burn in backgrounds and stuff. So I did order one, and let's get into the testing to see if it was worth the investment. Machine Basics. The ProStormer has an 8-pin threaded port that the handset cord connects into. This provides a very secure connection that isn't going to accidentally come loose. The front panel has everything needed to run the machine. The on-off switch is at the bottom. The knob on the left controls the fan speed, which has a range of 1 through 8. The white buttons can increase or decrease the heat setting. The range is 100 to 500 degrees Celsius. The display shows the temperature, and there are 3 programmable buttons that you can set to specific temperatures. There are 4 nozzles included: a 12mm square, a 10mm round, an 8mm round, and a 5mm round. It also comes with a set of tweezers. This machine is marketed as a heat gun to shrink wrap plastic on electronics, so I'm sure that's what the tweezers are for. When the machine is first powered up, it briefly displays the last temperature. Then it shows 3 dashes indicating it is on standby. Once you lift the handset from the receiver, then the machine begins to warm up. It takes 15 to 30 seconds before the machine is hot enough to start burning wood. Return the handset back to the receiver, and the gun starts to cool back down to 100. You are supposed to leave the machine on during this cool down period. The higher the fan setting is, the quicker the machine cools down. I have the fan set at 4.5, and it took 2 minutes and 23 seconds before the 3 dashes appeared on the machine display. Once that happens, the machine can be turned off. This does not mean that it is safe to touch any of the metal on the heat gun. The nozzle registered 146.5 degrees Fahrenheit at the 3-minute 15-second mark. The metal barrel registered 185.5 degrees Fahrenheit at the 4-minute 16-second mark. Keep in mind that first-degree burns can start happening at 118 degrees Fahrenheit. Second-degree burns can start at 131 degrees Fahrenheit. Of course, the severity of the burn is also dependent on how long you're in contact with the metal, but the point of this is don't touch the metal immediately after you turn the machine off. In fact, don't touch the metal for a good 10 minutes after the machine is turned off. It took 8 minutes and 44 seconds before the nozzle cooled down to 100.4 degrees Fahrenheit, and it took 12 minutes and 25 seconds before the barrel cooled down to 104.4 degrees Fahrenheit. It was at this point I felt comfortable touching it. I'm starting out at a baseline of 45 decibels. This is well within the green zone of safe noise levels. Level 1, the fan registers 57 to 58 decibels. On levels 2 through 4, the fan stays in the low 60s decibel range. Fan speeds 5 through 7 register a mid to upper 60s decibel range. On the highest fan speed of 8, the decibel meter registers 73, which is approaching the noise level of a vacuum cleaner. It is the handset that makes the noise, not the machine itself. Nozzle Basics. Pick a nozzle and slide it over the end of the heat gun. Then use a Phillips head screwdriver to tighten the clamping screw on the nozzle. I recommend aligning the clamping screw opposite of where your hand will be because there is warm air that gets funneled back through the brackets on the clamping screw. With prolonged use, that air can get pretty uncomfortable. When you use a new nozzle for the first time, it emits some rather smelly smoke for a minute or so. Use the heat gun in a well-ventilated area during this time. After the initial warm-up, it doesn't happen again. I've got the 12mm square nozzle equipped on the heat gun, and I'm just playing around with it to see how it works. What surprised me the most with this is that the center of the burn is hollow. I was expecting the heat gun to work like an airbrush does. With an airbrush, the center is the darkest spot and the color gets lighter from there. I've switched to the 10mm round nozzle and I am getting donut shapes with soft edges. Since I tend to hold the heat gun at an angle, the left side is darker than the right. Holding the gun perpendicular to the board makes it difficult to see what's going on. Now I am attempting to create a smooth, uniform patch of color. I must say that it's not very easy. Part of that is because the center of the burn is hollow. Another factor is that I have the settings too high. Both the heat and the fan are on maximum, and that makes it harder to control the burn results. I have got the screen split to show the last two nozzles, the 8mm on the left and the 5mm on the right. Other than they produce a smaller burn result, they are performing the same as the 10mm nozzle. Now I will say that the hollow center on the 5mm isn't as noticeable when compared with the other nozzles. Fan impact. I am burning on birch plywood. I have the heat set to 400 and the fan dial set on 1. The 5mm nozzle is equipped on the gun. This produces results that are easy to see and control. I can get fairly smooth burn results. I've increased the fan speed to the next whole number. It is possible to adjust the fan in between numbers, say 1.75, but I am staying with the whole numbers. With each test burn, I try to create smooth, uniform color. Then on the far right of each burn, I hold the heat gun in place for a little bit to get darker results. I was just curious what it would do. As the fan speed is increasing, the burn results are getting darker. Also, the time it takes to burn the test patch is decreasing, so it's not taking as long to do. It is also getting harder to maintain smooth burn results, so this means that the color is getting a touch blotchy. Here's how the test results look. I am repeating the test, but this time I have the heat set on 500, which is the highest heat setting you can get on this machine. The bottom burn is being done on birch plywood. The top burn, framed in red, is being burned onto basswood. At this high heat, most of the burn patches are very dark. They aren't smooth looking, and there is a lot of overburn. Here's how the boards looked after I was done with these last two tests. Heat impact. For this test, I have the 5mm round nozzle equipped. The heat is on the lowest setting of 100 degrees Celsius, which is 212 degrees Fahrenheit. After burning over the area for over a minute, I still couldn't see a color change on the wood at this temperature. I increased the heat to 200 degrees Celsius, and after a little bit, I thought I could detect the slightest hint of a color change on the wood. With the heat set at 300 degrees Celsius, I get a tan burn result that's easy to see and control. I am able to create fairly smooth shading in this square. A heat setting of 400 degrees Celsius produces a brown burn result that can be controlled to get a fairly smooth burn result. The maximum heat of 500 degrees Celsius also produces a brown burn result, but this burn is much harder to control and keep smooth and uniform in color. Here's how my test grid looked once I was done. I repeated this test using a piece of basswood, and I got results that were very similar to those that I got on the birch plywood. One noticeable difference was that the basswood results were smoother and more uniform looking, but I don't know if that's because of the different wood or if I was getting better with my use of the heat gun. Here's how the test board looked after I was done. Nozzle impact. I have a metal ruler taped to the handset. This ensures that the distance stays a constant 3/4 inch from the board. The 5mm nozzle is equipped, the heat is set on 500, and the fan level is on 6. With this setup, the nozzle is quickly creating dark donut shapes on the board. Ignore the test row that is below the area I'm working. I didn't think to time the burns, so I started a new test strip. After 30 seconds, I ended up with very blotchy results. Next up is the 8mm nozzle. The distance, heat setting, and fan speed remain unchanged from the 5mm test. I am getting similar dark, blotchy burn results. The large 10mm round nozzle produces a much wider burn result that isn't quite as blotchy as the previous two nozzles. The air is very diffused with the 12mm nozzle. I have to hold it in place for a longer amount of time to get noticeable results. For testing round 2, I've moved the nozzle so that it is 1 1/4 inches from the board. The heat and fan settings remain the same, so the heat is still at 500 and the fan is at speed 6. It took 45 seconds to get noticeable burn results with the 12mm nozzle, and I didn't move the nozzle much. I did move the 10mm nozzle around a little bit. The burn results ended up being very nice and uniform in color. The 8mm nozzle darkened the board faster than the larger nozzles, but that was expected. I wasn't able to get uniform color with this nozzle. The 5mm nozzle hardly darkened the board. This surprised me because I was expecting it to at least be darker than the 10mm. Here's the final test board. The 8mm produced the darkest results. The 12mm had the most consistent results. The burns done further from the board are lighter in color, less blotchy, but they took longer to do. Darkness comparison. For this test, I am using Colwood's E-Shader and the ProStormer 5mm nozzle to see how the dark burns compare to each other. The Colwood is set to 5.5 and I'm using the heavy-duty side of the burner. With the ProStormer, I've got the heat set to 500 degrees and the fan set on 8, which is the maximum setting for both items. Both burners are producing dark results, but the Colwood is staying within the boundaries of the square, whereas the ProStormer has a lot of overburn that has gone well beyond the square boundaries. Now I am doing a super dark burn by holding the burners in place. Why am I doing this? I have no idea. I don't recommend doing this, especially if you're burning on plywood like I am. The Colwood produced a very dark brown to black burn result, whereas the ProStormer produced a pitch black result. I couldn't get the camera to pick up the color difference. When I angle the board, you can see that the Colwood gives the board a uniform satin sheen that seals or compresses the wood. The ProStormer doesn't change the texture of the wood, and it produces a matte burn. Well, except in the spots where I excessively charred the wood. That got a bit of a satin sheen to it. I wiped a clean cotton swab over both burns. There was a little bit of carbon pickup on the Colwood side, but there was a lot of carbon pickup on the ProStormer side, and that's not surprising since it burns more like a torch, just without the open flame. Timed burn. I wanted to see how long it would take to fill in a 2-inch square with color. I'm starting out with Colwood's E-Shader. I rotated the board because I'm burning on plywood and it is much easier to burn with the grain. It took me 8 minutes and 14 seconds to burn in the square using the Colwood E-Shader. Next up was the ProStormer. I'm using the 5mm nozzle, the heat is set to 400, and the fan is on speed 4. This square took 4 minutes and 55 seconds. With each new square, I used the nozzle that was the next size up. I kept the heat and the fan setting the same. As the nozzle size increased, the time it took to fill in the square decreased. The time saved ranged between 3 and 5 minutes, and I thought the time savings were pretty impressive. Here are the final results. The Colwood E, 8 minutes 14 seconds. The 5mm nozzle, 4 minutes 55 seconds, which is 3 minutes 19 seconds faster than the Colwood. 8mm, 4 minutes 2 seconds. 10mm, 3 minutes 49 seconds. And the 12mm was 3 minutes and 23 seconds. Paper. The heat gun made the paper curl almost immediately, so I stopped the test. I got a fresh sheet and secured it to a backer board. I'm using heavy cardstock, and that's as much as I remember about this paper. The 5mm nozzle is equipped and the heat is set to 500. I'm incrementally increasing the fan speed, and the paper colors very quickly even on fan speed 1. I really should have used a lower heat setting for paper. Despite this, the test burns are fairly smooth looking. Even though the paper is taped down and I'm burning in a small area, the paper started to buckle as I neared the edges of the paper. The heat also caused the tape to shrivel up. Now I am trying to create smooth uniform color in a larger area. While it is possible to do this, the paper buckles as I get close to the edge. The next thing I did was test how dark of a burn can be created, and the answer is very dark. See this bright spot the yellow arrow is pointing to? That is the spot where the paper caught on fire. I saw the bright spot and promptly quit burning. What I didn't notice was that the paper was still on fire. I'm busy working on the next test as the paper continues to burn. I think what made me finally notice it was that the hole in the paper was getting larger. This experiment also damaged my backer board. Last thing I did was a carbon check on the burn, and it came back with a fair amount of carbon. Leather. I started out with a really thin piece of scrap leather that I used for test burning on. The burn marks appeared very quickly on the leather. I like how dark the burn marks were, but the hot air made the leather buckle and warp almost immediately. I got a piece of thicker leather and tried it. The thicker leather also curled up from the hot air. The white stuff forming around the burn is waxy bloom. It is a sign of poorly tanned leather, something I didn't know about and had never heard of when I bought the leather. After burning a hole in the paper, I decided to see how dark of a burn I could create on leather. I could get very dark burn results, just like I could on everything I tested. The darker and hotter that the leather got, the more it tended to buckle and curl. I did heat the back of the leather to see if that would remove some of the curling. It worked, but it didn't remove all of it. Lastly, I did a carbon check, and a little bit of carbon rubbed onto the cotton swab. Shields, stencils, and charcoal. I tried using the heat gun to create the thin bands of color representing ripples in the water. This didn't work very well because I couldn't make the heat gun be that precise. I tried using metal shields to help direct the airflow, and I got better success with that, but it wasn't close to the precision that I could create with a pyrography pen tip. Here's a before and after comparison. I just didn't care for how blotchy the burn results were with the hot air gun. I'm using a brass stencil to burn a tiny butterfly onto the board. The gun needs to be perpendicular to the board to get even results, but that angle makes it hard to see what's going on. I ended up with a fuzzy butterfly, and that's because the air blows under the stencil. This time I've got some pliers to help hold the stencil to the board. I'm hoping this will help prevent the air from blowing under. It is difficult to tell if I've missed a spot or how dark the burn is getting. I kind of like the results, and I can tell that the pliers helped as the left side has much better definition than the right. Next I tried the stencil on paper. I didn't burn as long because I knew the paper would darken quickly. A word of warning, these little brass stencils get hot. But I do think that the stencil works fairly well on paper. What you see is a compass test burn from another project. I am trying to see how close I can get to the compass without overburning onto it. By angling the nozzle away from the compass, I can get fairly close, but not right up to it. I am also burning a large area next to the compass in an attempt to create smooth, uniform color on a large scale. During this burn, I decided to try white charcoal to mask areas that I didn't want to darken up. I often use white charcoal as a mask to help me easily see areas I want to avoid burning over. Plus, the charcoal will resist the heat, that is, when you use it with a pyrography pen tip. I found out during this test that charcoal does not block any of the airgun heat. If anything, it bonded the charcoal to the board. This idea was a complete failure. Heat gun art project. Now that I'm feeling like an expert with this heat gun, I decided to create an art project using nothing but the heat gun and some metal shields. I sketched in a couple of seashells. I'm sure you recognized them immediately and didn't need me to tell you what they were. Using shields to control the application of color is very similar to methods used by airbrush artists. Since I have dabbled with airbrushing, I figured this was going to be a very easy project to do. Once I was done with my seashells, I thought they looked decent. Not awesome, but decent. That is, until I erased the pencil lines. Then they didn't even look decent. I asked Todd what he thought my artwork looked like. His response? Ugly, weird clouds. Guess I'm not an expert after all. Examples and tips. To get a background with tonal variety, move your hand in a sporadic manner. This means you should alter your hand speed, the burn direction, and how close to the board you are burning. This style of burning produces areas of light and dark tonal values. How light or dark depends on the nozzle used, the heat level, and the fan speed. For this example, I had the 8mm equipped, the heat was set to 450, and the fan was on speed 6. I used the tonal variety burn method on the barn owl. The reason is because I wanted the background to be darker, but I didn't want it to be uniform in color or perfectly gradient. I wanted some texture or tonal variety in the background, so this burn method worked well. The 5mm nozzle is equipped, and the heat is set to 400. The fan speed is on level 4. Using the heat gun took me less than 3 minutes to darken up this corner. It would have taken me 30 to 50 minutes using a pyrography pen tip. Here's the before and after comparison photo. To get a more uniform burn result, move your hand in a sweeping motion from one side of the board to the other. You can do this horizontally or vertically. Keep your hand speed and distance from the board constant as you burn. I have the 8mm nozzle equipped, the heat is set to 450, and the fan speed is on 6. I am generally moving my hand left to right, but I also did some vertical burning. If you compare this burn to the one below, you can see that this style of burning produces more uniform color. I used the uniform color style of burning to darken the water on my hooded merganser artwork. With this artwork, I wanted to increase the overall darkness of the water so that the duck would stand out better. To help ensure I don't get blotches, I'm using the 10mm nozzle, the heat is set to 400, and the fan is on level 4. Burning at lower heat and fan settings makes it easier to control the burn results, so I can get softer, fairly uniform color. I use a metal shield to cover the duck when I get near it. This ensures I don't accidentally darken up the white feathers on the chest. Here's how the duck looked before I darkened the background, and how it looked after I was done. I need to restore some of the darker ripples in the water, but the duck stands out better. Pros and cons. Let's start with the pros. The direction of the wood grain doesn't matter. It fills in areas much faster than a pyrography pen tip does. You can use metal shields and stencils. It doesn't alter the wood surface. It won't create gouges or divots into the surface. It provides better coverage on plywood. There's no missing slivers of wood. You can get very dark burn results on leather, paper, and wood. It's easy to create soft edges and out-of-focus shapes. It's a great substitute for open flame torches, and for me, a lot safer to use. Now for the cons. It's not very precise, even when using a shield or a stencil. The center of the airflow or burn is hollow. It quickly curls leather and paper. It dries out the wood, so thin wood is likely to bow and warp. It takes a long time for the machine to cool down. It heats up a room. I won't use it on hot days. It is difficult to get smooth, uniform color. On higher fan settings, it's a bit loud, at least to me. Is the machine worth it? For me, that answer is yes. It has saved me numerous hours of burn time. If you want soft, out-of-focus backgrounds that can be done quickly, or you like using a torch, I think you'll like the heat gun. If you don't do backgrounds, or your backgrounds are detailed and need precision, then I don't think the heat gun would be of value to you. Well, that's it for this product review. On my website, Pyrography Made Easy, I do have a written version of this product review. I will have a link to that blog in the description below. I will also have a link to the heat gun in the description below. Well, thank you so much for watching my video, and I will see you next week.